Hi students, in this video we'll be discussing about important questions of Abhyasa Deepika from the chapter Classification of Elements, the Periodic Table. First of all, we're discussing in this first section questions, that is very short answer questions. And what are the questions and how to write the answers for these particular questions if they come in the examination, board examination, or they coming uh, pre-board examination, or maybe in SA1 examination, what will be the case. Now, in the first question given in Abhyasa Deepika is, first question is, I will read out. Write the electronic configuration of Na plus and Cl minus ions. Write the electronic configuration of Na plus and Cl minus ions. Okay, so Na plus ion is nothing but Na is sodium metal, and Na plus means this is a cation. Okay, now first of all writing the configuration for Na plus ion. Na plus ion nothing but this is a sodium cation. As we know, sodium atomic number is 11, and it contains, sodium atomic number is 11, it contains 11 electrons are there in sodium. Now if you write the configuration, in my previous videos about electronic configuration and different principles, you will be getting in my previous videos. So if you observe previous videos, and you can understand how to write the electronic configuration. Now if you write the electronic configuration of sodium, it is a 1s2, 2s2, 2p6, 3s1. No, actually this is a configuration for sodium, which is a metal. And what he has asked is to write the electronic configuration for Na plus ion. So when this Na is converted into Na plus ion, nothing but cation, means if it loses electrons. If sodium loses electrons, sodium metal configuration, that is 1s2, 2s2, 2p6, 3s1. If I write shell level configuration 2, 8, 1, if the sodium loses 1 electron, it is going to convert into Na plus 1. Na plus or Na plus 1, both are same only. The configuration will become 1s2, 2s2, 2p6. So, and shell level configuration 2, 8. Okay, and 1 electron is lost by the sodium. Hence, when it loses 1 electron, it's going to convert into ion, which ion means cation. So, the configuration will become, if it losing 1 electron means it becomes much stable. So, if you ask you the question, sir, among Na and Na plus, which is more stable, means I will say directly as Na plus ion is more stable compared with Na. Reason is, after losing 1 electron, it is going to get octet configuration. Nothing but indirectly the configuration of which element of the periodic table means neon, which comes at inert gases. Okay, it becomes stable electronic configuration. So the electronic configuration of sodium Na plus ion is, finally the answer is 1s2, 2s2, 2p6. This is the answer. Okay, now if I talk about Cl minus ion, that is chloride ion. Nothing but chloride, minus means anion. Now chloride anion. Now if I write a Cl minus ion configuration, you know chlorine is a non-metal. Chlorine atomic number is 17. You must and should know about atomic number and even the basic configuration of the element chlorine. That is, chlorine atomic number is 17. It contains 17 electrons. If I write the configuration, it is 1s2, 2s2, 2p6, 3s2, 3p5. This is the configuration. Now, here chlorine configuration is this much, and Cl minus ion means chlorine is going to gain 1 electron. Now, if chlorine gains 1 electron, nothing but 17 plus 1 electron. So, it is electron gaining means it is going to gain negative charge. So, 1 electron is added to the 17 electrons. That is especially to the last 7 electrons, 1 electron is going to add. Then, it will become, after adding 1 electron, so it is going to convert into Cl minus with 18 electrons. Now if I write the configuration for this one, it is 1s2, 2s2, 2p6, 3s2, 3p6. Again, if you observe the last shell, here 1 is there in front of 1s, it is first shell. In front of 2s and 2p, we have 2 is there. It comes on second shell. In front of 3s and 3p, we have 3 is there. Okay, so this comes under third shell. And that these are the electrons. 2 plus 6. After adding 1 electron, 5. After adding 1 electron to chlorine, it is going to convert into 5 is going to convert into 6. So total how many electrons are there? 8 electrons are in the last shell. Stable configuration. So chlorine configuration is 1s2, 2s2, 2p6, 3s2, 3p5. Whereas chlorine ion, nothing but which ion? Anion. Configuration is 1s2, 2s2, 2p6, 3s2, 3p6. It is again octet configuration. Sir, can you tell after adding one electron, after taking one electron, that is Cl minus ion is formed, and what configuration it is which elements configuration it is, means that is argon configuration, which is becoming more stable. So if you ask me the question, sir, among Cl and Cl minus ions, which is more stable, means Cl minus, because it is gaining what configuration, means octet configuration. That is 8 electrons are there after gaining 1 electron. It is much stable. I hope you understood both the configurations. For that is one is for Na plus, another is for Cl minus ions. Is it clear? Now the next question. An element with atomic number 21. What is the place of the element in the periodic table? Why? Okay, an element with atomic number. Okay, the question will be displayed on the screen. Just go through the question once. An element with atomic number 21. Element atomic number given is 21. What is the place of the element in the periodic table? Why? So you have to find out the position of this particular element with atomic number 21. What is the position of this? To find out the position and even the element name, basically, you should know how to write the electronic configuration. So the element with atomic number 21 contains 21 electrons. And if you write the configuration based on Moller's diagram, okay, now atomic number 21 contains 21 electrons. If you write the configuration 1s2, 2s2, 2p6, 3s2, 3p6, that is next one is 4s2, 3d1. This is simply we can write very easily based on Moller's diagram. Okay, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Now if you observe this particular configuration, now we can compare, for example, 1s2 is there, you can compare with an LX method. Okay, here n denotes n is equal to 1 here, that is shell number. Okay, L denotes subshell, that is we are having s orbital here. Okay, X denotes number of electrons, remember that. So in any given configuration, if you observe the entire configuration of that particular element, then you have to understand one thing, which orbital, okay, which orbital having more n value here, 1s orbital or 2s orbital, 2p, 3s, 3p, 4s, 3d. So among all these, the n value is maximum for 4s. So here n is equal to 4. So n value which we are going to write in front of the respective orbital, okay, that gives rise to the period number. The n value gives rise to period number. Now among all these, if you just watch, okay, n value will be maximum for 4s. So compared with the 1s, 2s, 2p, 3s, 3p, 4s, 3d, among all these, the maximum n value is for 4s orbital. That is, n is equal to 4 means this gives rise to period number. And next, one more thing you have to understand. Now, if you count the number of electrons, okay, here the total number of electrons, how many here? That is 4s2, 3d1. So we are having this is a electron, last electron is in a d orbital. Now it comes under, if you write, you can write even d block. It comes under d block, first point. Okay, period number is 4. And block is d because electron is in d orbital. One way. And next one is how many number of electrons are there? No, this is 1s2, 2s2, 2p6 octet configuration, 3s2, 3p6 octet configuration. Now if you count these two number of electrons, 2 plus 1, how many? 3 are there. So 3 electrons are there. It comes under, 3 electrons are there. It comes under third group. That too, third B group. Third B group. Okay. So that is third B group and it is D block. D orbital is there. D block element, third B group, and period number is 4. And I can say the element name is scandium. Element name is scandium. 21 atomic number means scandium only. It comes under D block, that is transition element, transition metal, and it belongs to 4th period. And next one is D block, and the group number is 2 plus 1. How many electrons are there total? Last, if you consider, that is 3 electrons are there. It comes under third group, that is third B group. Is it clear? So, sir, 3 electrons are there. It may come under third A group. You may get one doubt. No way, because we are having is d orbital here. So in case of p block elements, we won't get a d orbital. Okay, at the end. In case of p block elements, we are getting p orbital. So purely we have d orbital here. It comes under d block. D block in the sense all b group elements are there. 1a, 1b, 2b, 3b, vagera vagera. So hence it comes under d block. That is transition elements, and even the element name is scandium we have, and the shell number is n is equal to 4 na? So hence it comes under fourth period, D block, and even 3 electrons are there. That gives rise to group number here. That is third B group. Is it clear? I hope you understood. Okay. Now the third question. Arrange the following elements in the increasing order of their atomic radii. Elements was given is. Okay, we have is arrange the following elements in the increasing order of their atomic radii. That is, first one is phosphorus given, next is aluminum. The question will be displayed on the screen. Just you see the question once. Phosphorus, aluminum, chlorine, sodium, and next element was given is sulfur. Next is silicon. Next is magnesium. So in the increasing order of their atomic radii. Now we should know their atomic number even. At least you should know the atomic number. Without knowing the atomic number, without knowing the there is how many shells are there in that, which shell the last electron is entering, and without knowing which period, which group, we cannot tell directly like that. Okay, now we have the elements. Now phosphorus. Okay, phosphorus atomic number is 15, aluminum is 13, chlorine is 17, sodium is 11. Next one is sulfur. Okay, sulfur is 16. Okay, silicon is 14, magnesium is 12. So these are the atomic number. Now we have, if you write these atomic numbers in the order, in sequential order, in a perfect ascending order, first one comes under is sodium here, 11. Next one is magnesium, 12. Next one is aluminum, 13. 14 one is, that is a silicon, 14. And next one is phosphorus. Phosphorus is, that is, next one is phosphorus, 15. And next one is sulfur, 16. Next one is chlorine, 17. Now, if you know the atomic numbers, then you please initially write the atomic numbers of all the elements which were given here in the ascending order, first of all. Now, you need to think about configurations. Now, if I write the configuration sodium, atomic number is 11, 11 electrons, configuration is 1s2, 2s2, that is 2p6, 3s1. Magnesium anyway, 12 means class shell. If I write the configuration for magnesium, it is 1s2, 2s2, 2p6, 3s2. And aluminum is 1s2, 2s2, 2p6, 3s2, 3p1. Now, here is silicon is 1s2, 2s2, 2p6, 3s2, 3p2. Now, if I write out for phosphorus, now for phosphorus I am writing here. Phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. And for sulfur, okay, 1s2, 2s2, 2p6, 3s2, 3p4. Next one is chlorine, 17 atomic number, 1s2, 2s2, 2p6, 3s2, 3p5. Now, one common thing I think you all observed, that is, here in case of sodium, last electron comes under third shell. So, for this case also, third shell. 3s2, third shell. 3s2, 3p1, third shell. 3s2, 3p2, third shell. 3s2, 3p3, phosphorus also third shell. Sulfur, 3s2, 3p4, third shell. Chlorine, 3s2, 3p5, third shell. So, commonly we can understand that what is common among all these elements is last electrons are coming under third shell. So, hence all these belongs to third period. First of all, you should remember like that. All these belongs to third period. So, all these are belonging to what period means? Third period. Now, I will write here. It's better to write here. Third period. And here, third period, all these elements comes under third period. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. And last element, if you write, if it is not there, not mentioned, it is argon actually. So all these are coming under third period. And we are moving from left to right. Okay, in case of groups, in case of periods, as we are moving from left, this is a period, third period. If you remember atomic radius definition and how the atomic radius will vary in groups and periods. In groups, as we are moving from top to bottom, atomic radius will increase. In periods, as we are moving from left to right, the atomic radius most commonly decreases. Okay, it decreases from left to right. So among all these elements, okay, the highest atomic radius is for sodium. More atomic radius is sodium. The question is, if you go through the question, arrange the following elements in increasing order of the atomic radius. Highest is sodium. Okay, first highest atomic radius is sodium. Next, little less, somewhat, so compared to sodium, less atomic radius is magnesium. Aluminum further decreases. Silicon further decreases. Okay, phosphorus, it becomes stable. Okay, it becomes stable element. It may show somewhat increase in atomic radius. Okay, and sulfur further decreases. Chlorine further decreases. So most commonly, if you observe, if you arrange the elements, the increasing order of the atomic radius, the least atomic radius element is chlorine. Okay, next one is sulfur. Okay, next one is phosphorus may become stable. Okay, because of stable electronic configuration. So next atomic radius is somewhat more is, here is, if you write, this is a phosphorus, and here is next is silicon, and next is aluminum, and next is magnesium, at the end sodium. So the atomic radius is increasing. Okay, highest is for sodium, next somewhat least is for magnesium. He asked the question, arrange the elements the increasing order of the atomic radius. So atomic radius is highest is for sodium. Increasing order is same. So sodium is having highest. Next somewhat less is magnesium. And next less is aluminum. Next is silicon, phosphorus, sulfur, chlorine. Is it clear? So this is the question. And please try to remember how to identify, okay, the element, whether it comes under which group or which period. All these comes under different groups, but they belongs to same period. So if all these are coming under same group, they may have different kind of arrangement here, depending upon the position of the element in the group, whether it is coming first or second in the group, somewhat. Okay, I hope everybody understood this. Now the next question is, why do elements present in the right side of the periodic table have least values of electronegativity? Why does the elements present in the right side of the periodic table are having least values of electronegativity? Actually, they would never be having least values of electronegativity. They are having more values of electronegativity, but only one group elements, which are called inert gases, are having zero values of electronegativity. I will explain. Okay, the question asked in different way here is, why do the elements present in the right side of the periodic table have least values of electronegativity? The question is, why do the elements present in the right side of periodic table have least values of electronegativity? That was the question. Actually, in my view, the question is not clear here. Reason is, the elements which are present towards right side are having highest electronegativity values. They are having a highest electronegativity values, not least. Only 8th A group elements, nothing but noble gases or inert gases or zero group elements, are having a zero electronegativity values because they are having octet configuration. As we are moving, common factor if you consider, as we are moving from left to right in the period. For example, now if I talk about the second period elements, lithium. Okay, if I talk about second period elements, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So these are second period elements. Okay, as we are moving from left to right, the electronegativity values will increase. They never decrease. Why they are increasing? The reason is the atomic radius is decreasing. Now if I talk about lithium, lithium atomic number is 3. Configuration is shell level 2, 1. If I write configuration orbital level 1s2, 1s2, 2s1. Now if I talk about beryllium, atomic number is 4, 1s2, 2s2. Now if I talk about boron, 1s2, 2s2, 2p1. Here it is carbon, 1s2, 2s2, 2p2 for carbon. And for nitrogen, if I write here, 1s2, 2s2, 2p3. Oxygen, 1s2, 2s2, 2p4. This is for oxygen and this is for nitrogen. And here it is for carbon. Here it is for boron. And fluorine, 1s2, 2s2, 2p5. And for neon, 1s2, 2s2, 2p6. So if you think about the configurations, now here last electron comes under second shell. Here also last electron comes under second shell only. So all these elements are belongs to same period. So if I compare their sizes, the atomic radius is more for lithium compared to the beryllium. Okay, compared with the beryllium, the atomic size is less for boron. It is further decreases. It is somewhat not that much decrease in value. Okay, it may be affected because stable configuration. Now oxygen is having less atomic radius. Fluorine further decreases. Near anyway octet configuration. So as we are moving from left to right, the atomic radius commonly what we are observing is atomic radius is decreasing. As atomic radius is decreasing, the attractive force between the nucleus and the shell electrons will increase. As attractive force is increasing, it is very easy to gain the electron. The electron will be pulled easily towards the nucleus, hence the shell size may decrease. The shell size may decrease because of more attractive force, hence the atomic radius may be affected. More attractive force, more electronegativity, less atomic radius. Okay, so as we are moving from left to right in case of periods, common factor of atomic radius is decreasing. As atomic radius is decreasing, electronegativity will increase because more attractive force towards the nucleus. The atom will try to take the electron more easily because size is less, more attractive force towards the nucleus. Now if I take this is the nucleus and here is first, in case of lithium if you take 2 electrons are the first, second shell only 1 electron is there. If I go with the fluorine, okay, fluorine nucleus, and nucleus is having a plus 9 charge, here nucleus plus 3 charge, and first shell to second shell how many are there? That is 7 electrons are there. Now compared with this one, the attractive force is more towards the nucleus in case of fluorine compared to the lithium because 7 electrons are there. 7 electrons are there, last shell, and in the nucleus we have 9 protons are there. 9 positive charges are there, 7 electrons are there. If I give one more electron, it readily takes. Hence, the gaining ability of the electron for this particular fluorine is more compared with the lithium, as size is less. Size is decreasing because of more attractive force. So it readily take the electron. Hence, the electronegativity values, common factor if you consider, it increases from left to right, it never decreases. There are some certain instances, maybe because of stable configuration. In case of neon, which is net gas, it neither lose nor gain electrons. So hence the electronegativity value is 0 for neon. Compared to the fluorine, neon is having 0 value. But among all these elements, the highest electronegativity value is fluorine. So according to my view, according to the referred books, we can consider the electronegativity values will increase from left to right. They never decrease. Is it clear? Okay. Now the next question. Why do nitrogen have less electron affinity value compared to oxygen? There is a very, very important question. Why does nitrogen have less electron affinity value compared with oxygen? That is simple understanding, stable configuration. Why does nitrogen have less electron affinity? Okay, nitrogen and oxygen. Why? The question is, why does nitrogen has less electron affinity electron affinity than oxygen. That is, than oxygen. So, what is electron affinity? It is the amount of energy released. Okay, when an electron is added to a neutral gaseous atom, is called as a electron affinity. Nitrogen and oxygen we are comparing. Nitrogen atomic number is 7. It contains 7 electrons. Oxygen atomic number is 8, contains 8 electrons. If I write the configuration, it is 1s2, 2s2 and 2p3. Here it is 1s2, 2s2, 2p4. Some will pronounce as 1s square, 1s square, 2s square, 2p4. But is to understand there is 1s2, 2s2, 2p4. Now if I write orbital level configuration, and this is 1s2, 2 electrons and 2s2, 2 electrons and 2p, as I explained in my previous session related to atomic structure from Abhyas Deepika questions. Okay, so we are having P is having 3 degenerate orbitals. They are 2px, 2py, 2pz. So we are having 3 electrons are there, 1, 1, 1, stable. Okay, and here it is orbital level configuration for oxygen is 1s2. 2 electrons are there. And 2s2. 2 electrons are there. And we are having is 2p. This is 2px1, 2py1, 2pz1. Here is 1 electron, 1 electron, and 1 more electron. 4 electrons are there. 1 more electron fill here. 2px2, 2py1, 2pz1. Now if you observe the configurations, here it is 7 electrons. Atomic number 7, 7 electrons. 1s2, 2s2, 2p3. P orbital is half filled. And here it is 8 atomic number, 8 electrons, 1s2, 2s2, 2p4, more than half. So, as we discussed in my previous videos, that electronic configuration, according to electronic configuration, which is more stable, means half-filled configuration, orbitals with the half-filled electrons are more stable compared with the more than half or less than half or less than fully filled orbitals. Okay, so half-filled orbitals and fully filled orbitals are more stable compared with any other orbital number of electrons. Okay, so among nitrogen and oxygen, nitrogen is having half filled p orbital, that is 2p6 completely filled means 2p6 in p orbital, and half filled means 2p3. It is more stable compared with the oxygen. Okay, so as it is more stable, the electron affinity value is lesser compared with the oxygen. Oxygen is having a more electron affinity values. Reason is, okay, reason is, what is electron affinity? It is the amount of energy released when an electron is added, okay, to a neutral gaseous atom is called as electron affinity. So oxygen can able to readily take the electron more easily compared to the nitrogen, because nitrogen is stable, very stable because of half-filled configuration. Okay, it is not fully filled but half-filled configuration, more stable compared to this one. So it can able to take the electron more easily compared to this one. So as compared to the nitrogen and oxygen, oxygen is having more electron affinity than nitrogen. And one more way we can understand, size. Nitrogen is having somewhat more size compared to oxygen. Atomic radius is less for oxygen and somewhat more for nitrogen. Left to right, as we are moving from left to right, atomic radius decreases because as these two elements comes under same period. Now if I write the order of the elements comes under this particular period, if you consider lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So we have nitrogen and oxygen. As we are moving from left to right, the atomic radius decreases. So compared to the nitrogen, oxygen is having less atomic radius. So more attractive force towards the nucleus. Is it clear? So electron affinity value is more for oxygen compared with the nitrogen as the size is affected here. Oxygen is having less atomic radius compared with the nitrogen. Hence, electron affinity values are more for oxygen compared with nitrogen. So hence, as we are moving from left to right, electron affinity values will increase, and even electron negativity values are also increasing. Remember that in case of periods. Okay, I hope everybody understood this very short answer questions explanation. Okay, next we will continue the part 2 of periodic table of elements, that is classification of elements, the periodic table, part 2 in the next video. Thank you.